So the second section, and the only other section that we're going to talk about in Chapter 4, talks about how to graph rational functions and just the basics behind them. And we talked a little bit about this in class, and if you've seen the videos for section 4.1, you saw a little bit about this already. So just to kind of understand a couple things about this, when you're sketching a graph, there's a few things that you need to know. Okay, if you're asked to sketch the graph, the first thing you want to know are a few things about it. And what I would usually start with is first asking yourself, where is the y-intercept? Well, that's where the graph hits the y-axis, and that's where x is equal to 0. So if we can find out where x is equal to 0 in this, we'll get a point on this graph. Well, if I plug in 0, I get 3 over 0 minus 2, which is 3 over negative 2. So this point is on the graph. It's also interesting to talk about specifically where the x-intercept on any graph would be. So trying to find out where this graph would hit the x-intercept. Now I'm going to talk about this in two different ways, but if you set y equal to 0, we have something that looks like this. Now we're saying 3 divided by something gives us 0. Now if we multiplied both sides by x minus 2 to get rid of the denominator, we'd be left with 3 equals 0. And you can't have 3 equal to 0. So that's not true, so there's no x-intercept. And there's another reason for why that's true, and I'll talk about that in just a second. So there really isn't an x-intercept, so I'm just going to cross that off. So I know a y-intercept, I know there's no x-intercept. Now I need to talk about where there is a vertical asymptote. Vertical asymptotes are where the function doesn't have a value evaluated at the denominator. So if we look at this, where is there a 0 in the denominator? Well, in this function, x minus 2, it happens at x equals 2. So this is my vertical asymptote. And it's also important to know that wherever there's a vertical asymptote, this is going to be a point that's not in the domain. So this is not in the domain. So this value, 2, is not going to be in the domain of this function. So now I've talked about the vertical asymptote. Now let's talk about the horizontal one. If you look at this graph, we have 3 over x minus 2. We have a degree 0 over a degree 1. So if you have a degree 0 over degree 1, that means that we have a higher degree in the denominator. So that means that this line, or this curve, follows the x-axis, which means the line y equals 0 is a horizontal asymptote. So we have all this information. Now what we need to do is we need to look at this and say, all right, let's use all this information and find some additional points. We know it goes to the point 0, negative 3/2. We know that there is a vertical asymptote at negative or a positive 2. So this is a line that it's not going to cross. And we know that in the end that this graph is going to eventually go across or follow the x-axis. Well, let's see what happens when I get closer to this horizontal or vertical asymptote. If I pick 1 for this graph, what happens? Well, I get 3 over a negative 1, which is a negative 3. So that goes down. So what this graph looks like is something like this. And then going left will go this way. Now, I'm going to plot another point on the other side of the asymptote. Let's plot maybe 3 and 4. So at 3, the graph is equal to a positive 3. So I'm going to plug that point in. At 4, the graph is equal to a 3/2. So that's going to be about here. So the way that this graph looks on this side of the asymptote would be something like this. And again, as you go farther left, it's going to try and get closer to the x-axis, or y equals 0. As you go farther right, it's going to try and get to the x-axis as well. But I want to just outline something here because you're going to see something in the book. As you are going towards 2, as x is getting towards 2, it has two different things happening. It's going negative and positive. So they use two different notations. They'll say things like this: as x approaches 2 from a positive side, and x approaches 2 from a negative side. So when you see that, just know that it's talking about how x is behaving on both sides of the asymptote. So this just means from the left or the negative side. This means from the right. One thing last I forgot. For the domain, we already talked about the part that's not in the domain. The only value that's not in the domain is the part that you can't use. Again, domain is the values that you can't use. And the only value that you can't plug in is one that doesn't work. And the one that doesn't work is the one that you can't get a value back. That's with the denominator of 0. That would be 2. So the answer for the stating its domain is x can't equal 2. So again, looking at this, if we're going to sketch a graph, we want to find the x-intercept. We're going to start with that. So I'm going to plug 0 in for x. If I plug 0 in here, I get -1. If I plug 0 into the denominator, I get 0, so that doesn't work. So that means there's no x-intercept. If I plug in y for a y-intercept and I try to figure out where y is equal to 0, or where it hits the y-axis, I should say, I got to be careful here because I said x-intercept, I meant y-intercept, because you plug 0 in for x for a y-intercept. For an x-intercept, you plug 0 in for y. So if I plug 0 in for y for this graph, let's see what happens. So this graph doesn't have a y-intercept, but it might have an x-intercept. So I get 2x minus 1 equals 0. Well, that's going to be at a positive 1/2. So the x-intercept for this graph is at 1/2, 0. Now we have to talk about vertical asymptotes. And again, vertical happens to be where the denominator is 0. And that's at just where x is equal to 0, because that only happens where x, or the denominator, is equal to 0. For horizontal, we have to look at the degrees of the two, and if you notice, both of them are degree 1. Both of these are degree 1. So what we do is we deal with the leading coefficients of both of them. The leading coefficient of the first one, or the numerator, is 2. The leading coefficient of the denominator is 1. So the horizontal asymptote happens at y equals 2. So in the next video, I'm going to take and just show you all this information, plot a few extra points, and then we'll go from there.